see this circuit. See, once again, operational amplifier. We are going to use once again the operational amplifier. Same pins 4, 7, 6, 2, 3, 5 pins. ಐದೇ ಪಿನ್ ಯೂಸ್ ಮಾಡೋದು, ಇನ್ನು 3 ಪಿನ್ ಯೂಸೇ ಮಾಡಲ್ಲ. 4 and 7th pin are always minus VSAT plus VSAT. Sorry, saturation voltages. Remember saturation voltages. 6th pin output, 2 and 3rd pin inputs. ಅದಕ್ಕೂ ಇನ್ಪುಟ್ಸ್ಗೆ ಬೇರೆ ಬೇರೆ ಹೆಸರು. ಒಂದು ಇನ್ವರ್ಟಿಂಗ್ ಇನ್ಪುಟ್ ಅಂತ, ಇನ್ನೊಂದಕ್ಕೆ ನಾನ್ ಇನ್ವರ್ಟಿಂಗ್ ಇನ್ಪುಟ್. ಪ್ಲಸ್ ಇದ್ರೆ ನಾನ್ ಇನ್ವರ್ಟಿಂಗ್, ಮೈನಸ್ ಇದ್ರೆ ಇನ್ವರ್ಟಿಂಗ್ ಇನ್ಪುಟ್ ಅಂತ. This is how the connection. The output here is square waveform. Relaxation oscillator which generates the square waveform, the input frequency what we have to give is 1 kilohertz. Then how we are going to design is the question. ಇಲ್ಲಿ ಏನು ಹೇಳ್ತಾರೆ ಕ್ವಶನ್, ಡಿಸೈನ್ ಅಂತ ಹೇಳೋದು. ಡಿಸೈನ್ ಅಂದಮೇಲೆ ಆ ತರ ಬರಂಗೆ 1 ಕಿಲೋಹರ್ಟ್ಸ್ ಬರಂಗೆ ನೀವು ಅದನ್ನ ಯಾವ್ಯಾವ ರೆಸಿಸ್ಟರ್ಗಳು ಯೂಸ್ ಮಾಡಬೇಕು, ಎಷ್ಟು ರೆಸಿಸ್ಟೆನ್ಸ್ ಯೂಸ್ ಮಾಡಬೇಕು, ಅದನ್ನೆಲ್ಲ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. In order to do that, we want a capacitor, we want resistor, load resistor, and these another resistors are required. ಈ resistance ಬೇಕು. See, the input waveform here is capacitor charging voltage, capacitor discharging voltage, capacitor charging. What the waveform what you are seeing is capacitor charging. ಇದೇನು ತೋರಿಸ್ತಾ ಇದೆಯಲ್ಲ ಕೆಪಾಸಿಟರ್, ಅದನ್ನು ಚಾರ್ಜ್ ಮಾಡ್ತಾ ಇದೀವಿ, ಅದು ಚಾರ್ಜ್ ಸ್ಟೋರ್ ಮಾಡ್ತಾ ಇದೆ. ಅಂಟಿಲ್ or what time the capacitor charges, the output from that waveform will be high output. ಇಲ್ಲೊಂದು ಕೆಪಾಸಿಟರ್ ಇದೆ ನೋಡಿ ಸಿ ಅಂತ, ಅದು ಎಷ್ಟೋ ತನಕ ಚಾರ್ಜ್ ಆಗುತ್ತೋ ಅಷ್ಟೋ ತನಕ ಔಟ್ಪುಟ್ ಹೈ ಬರುತ್ತೆ. when the capacitor discharges, the output will be low. ಕೆಪಾಸಿಟರ್ ಚಾರ್ಜ್ ಆಗುತ್ತೆ, ಹೈ ಔಟ್ಪುಟ್. Where exactly you can see this type of waveform? A battery gets charged, during that time some device will be off. When battery gets discharged, some device will be on. Where you can see these type of circuits. ಎಲ್ಲಿ ನೋಡ್ಬೋದು ಈ ತರ ಸರ್ಕ್ಯೂಟ್? Can anyone reply? Here exactly you can see a battery. Assume that a battery gets charged. During that time the output will be low. Battery gets discharged, the output will be high. In normal, in every day you used to see this. Every day you are going to see this. Murli Venkat, are you there? Idira Murli? Oh, so much of vibration, not required. Arshita? Arshita Idira? HM Arshita? Apeksha? Apeksha C?
Yes, sir.
ಈ ತರ ಎಲ್ಲಿ ಸಿಚುವೇಶನ್ ನೋಡಿರ್ಬೋದು?
ಗೊತ್ತಿಲ್ಲ ಸರ್.
ಯೋಚನೆ ಮಾಡಿ, ಒಂದು ಬ್ಯಾಟ್ರಿ ಚಾರ್ಜ್ ಆಗ್ತಾ ಇರುತ್ತೆ, ಅವಾಗ ಆಫ್ ಆಗಿರುತ್ತೆ ಸಿಸ್ಟಮ್. ಬ್ಯಾಟ್ರಿ ಡಿಸ್ಚಾರ್ಜ್ ಆಗುತ್ತೆ, ಅವಾಗ ಆನ್ ಆಗುತ್ತೆ. ಅಶ್ವಿತಾ? ಅಶ್ವಿತಾ? ಆ ತರ ಎಲ್ಲಿ ಬರುವ ಸಿಚುವೇಶನ್? Indicators in the vehicle, have you seen the indicators? Left right indicators.
Yes, sir.
There also there will be a small battery which gets charged. During that time it will be off and the battery gets discharged. In that time you will see the light. ಅನ್ನಿಸ್ತಾ ಅಟ ಮ್ಯಾಚ್ ಈ ತರ ಇರ್ಬೋದಾ?
Yes, sir.
Apeksha, in the indicators you can see this kind of relaxation oscillator circuit in the background.
Yes.
Okay, very slow. ನಿದ್ದೆ ಬರ್ತಿದ್ಯಾ?
ಇಲ್ಲ ಸರ್.
Okay. See, this is what in the relaxation oscillators, in the indicators, they are going to use this where the battery gets charged. Here, the reverse of that, we can reverse the output also. See, what happens, how we are going to calculate is whatever the input, what we give, what the design, we are going to discuss about the design now, how we are going to design. The input, what we have given is frequency. What is the frequency? F. What we are going to get from F, and with the example itself, we'll see. We have a formula here. The frequency is 1 kilohertz. This is what in the problem statement they have given. You are going to get the time. If you reverse of the frequency, you will get the time, 1 millisecond. We want to know how much capacitor we have to take, how much resistance you have to take. R1, R2 capacitor ಎಷ್ಟು ತಗೊಬೇಕು ಅನ್ನೋದನ್ನೇ ಇಲ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೊಬೇಕಾದ್ರೆ ಅಷ್ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಅದ್ರ ಪ್ರಕಾರವಾಗಿ ಔಟ್ಪುಟ್ ಬರುತ್ತೆ. ಫಾರ್ 1 kilohertz, the time will be 1 millisecond if you reverse of that. Here, three values we are going to fix. The capacitor charge ಆಗಕ್ಕೆ ತಗೊಂತಾ ಇರೋದು 0.1 microfarad. That much is enough. Bigger one you are not saying. Capacitor 0.1 microfarad. R1 and R2 resistors is 1 kilo ohm. This is fixed for any frequencies. For any frequencies, this is not variable. This is fixed. What is going to variable? The variable is this R. ಈ ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ ಇದು 1 kilohertz, ಇದು 1 kilohertz. This is called as a loop back or feedback op-amp. Feedback ಇದೆ, ಔಟ್ಪುಟ್ ಇಂದ ಮತ್ತೆ ಕನೆಕ್ಟ್ ಮಾಡ್ತಾರಲ್ಲ ಇದು ಫೀಡ್ಬ್ಯಾಕ್. These are called feedback resistors. ಈ ಫೀಡ್ಬ್ಯಾಕ್ ರೆಸಿಸ್ಟರ್ಸ್ ಏನಿದೆಯಲ್ಲ ಇದು ಫಿಕ್ಸ್ R1 and R2. ಎಷ್ಟು? 1 kilo. This is fixed. There is a formula here. In order to calculate the R1 and R2, we have a formula. Beta equals R2 by R1 and R2. T equals 2 RC ln 1 plus beta by 1 minus beta. ಇಲ್ಲಿಗೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ beta equals 1 by 1 plus 2, 0.5 ಏನೋ ಬರ್ತದೆ. ಯಾಕೆಂದ್ರೆ R1 and R2, we said that it is 1 kilo ohms. That is why, therefore, the beta will become here how much? This beta will become 0.5 kilo ohms because 1 by 2. Whenever you substitute here 1 plus 0.5, 1 minus 0.5, this will become 3. The ln of 3 will become 1.098. Equation has reduced to this much. Just bega simplify agobidu. T equals 2.196 RC. Now we have already said that capacitor ನಾವು ಫಿಕ್ಸ್ ಮಾಡ್ಕೊಂಡಿವಿ ಇಷ್ಟೇ ಫ್ಯಾರಡಿನ್ ಸಾಕು ಅಂತ 0.1 microfarad. Capacitors ಗೊತ್ತು, ಟೈಮ್ ಗೊತ್ತು, ಬಿಕಾಸ್ 1 kilohertz reciprocal is 1 millisecond. ಇನ್ನೇನು ಬರುತ್ತೆ? R ಬರುತ್ತೆ. This resistor 4.55 kilo ohms. ಏನ್ ಮಾಡ್ತೀವಿ? ಇಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡ್ತಾ ಔಟ್ಪುಟ್ ಟು ಸೆಕೆಂಡ್ ಪಿನ್ ಈ ರೆಸಿಸ್ಟೆನ್ಸ್ 4.5. ಇಲ್ಲಿ ರೆಸಿಸ್ಟರ್ಸ್ಗಳು ತಗೊಳೋದು 1 kilo ohm, 1 kilo ohm. ಇಲ್ಲಿ ಕೆಪಾಸಿಟರ್ಸ್, the capacitor is 0.1 microfarad. When the capacitor gets charged, ಇದು ಚಾರ್ಜ್ ಆಗೋವರೆಗೂ ಔಟ್ಪುಟ್ ಇಲ್ಲಿಂದ ಹೈ ಬರ್ತಾರೆ. ವೆನ್ ಕೆಪಾಸಿಟರ್ ಗೆಟ್ಸ್ ಡಿಸ್ಚಾರ್ಜ್, ಇಲ್ಲಿಂದ ಡಿಸ್ಚಾರ್ಜ್ ಆಗಕ್ಕಾರೆ ಲೋ ಔಟ್ಪುಟ್. Only for one frequency, if you show the output, it is enough. In your case, for only one output, if you show, it is enough. This is what theoretical value. Theoretical is 1 millisecond, frequency is 1 kilohertz. ಈ ಟೇಬಲ್ ಎಲ್ಲ ಬರೋದಿಲ್ಲ ಯಾಕೆಂದ್ರೆ ಒಂದಕ್ಕೆ ಎಲ್ಲ ನೀವು ಡಿಸೈನ್ ಮಾಡೋದು ಅಷ್ಟೇ ಮಾತ್ರ ಡಿಸೈನ್ ತೋರಿಸ್ಬೇಕಾದ್ರೆ. ದ ಡಿಸೈನ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ದಿಸ್ ಮಚ್. ಯು ಹ್ಯಾವ್ ಟು ಶೋ ದಿಸ್ ವರ್ಕಿಂಗ್. ಆರ್ ಏನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀರ ಅನ್ನೋದನ್ನ ತೋರಿಸ್ಬೇಕು. 4.55 ಹೆಂಗ್ ಬಂತು ಅಂತ ತೋರಿಸ್ಬೇಕು. This is what design. Then what you have to do? You have to do take the op amp, connect to 7th pin, 4th pin. ಇಲ್ಲಿ ಎರಡು ರೆಸಿಸ್ಟರ್ಸ್ ತಗೊಬೇಕು. You can see the output. Capacitor charging, high output. Capacitor discharging low output. Capacitor charging high output or capacitor discharging low output. However you want, you can design. High ಬೇಕು ಅಂದ್ರೆ high ಚಾರ್ಜಿಂಗ್ ಹಾಕರೆ, ಡಿಸ್ಚಾರ್ಜಿಂಗ್ ಹಾಕರೆ ಲೋ ಬೇಕು ಅಂದ್ರೆ ಲೋ. ಈ ತರ ಕನೆಕ್ಟ್ ಮಾಡಿ. Do you have any doubts in this? In the software, please try drag and drop. ಎಲ್ಲ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ಸ್ ಇಲ್ಲಿದಾವೆ. ನೀವು ಹಾರ್ಡ್ವೇರ್ ಅಲ್ಲೇ ಮಾಡ್ಬೇಕಂತಿಲ್ಲ. ಇಲ್ಲಿ ಜಾಸ್ತಿ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿದ್ರೆ ಹಾರ್ಡ್ವೇರ್ ಅಲ್ಲಿ ಚಕ ಜಲ್ದಿ ಕನೆಕ್ಟ್ ಮಾಡ್ಬೋದು. ಆಲ್ ದೀಸ್ ಕಾಂಪೋನೆಂಟ್ಸ್ ಆರ್ ದೇರ್ ಹಿಯರ್. ಎನಿ ಡೌಟ್ಸ್? ಯು ಕ್ಯಾನ್ ಆಸ್ಕ್. So many of us send the attendance and I think they have exit. They have left the meeting. How many are present? For them only I am going to mark the attendance. 48 members ಇದ್ದಾರೆ, ಈಗಲೇ 40 ಇದ್ದಾರೆ. ಏನು ಮಾಡಕ್ ಬಿಟ್ರಲ್ಲಪ್ಪ. Can anyone ask? Any doubts in this? Manoj. Amrut BU. ಇದ್ದೀರಾ? Amrut BU. Are you there? Amrut BU. If you don't reply, then I'll. What about Aditya? Aditya, are you there?
Yes, sir.
Have you understood about this relaxation oscillator?
Yes, sir.
What is the main application of this? Where exactly they use this? ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ ಅಪ್ಲಿಕೇಶನ್? ಬಿಗಿನಿಂಗ್ ಅಲ್ಲೇ ಹೇಳಿದ್ನಲ್ಲ, ಎಲ್ಲಿ ಈ ತರ ಸರ್ಕ್ಯೂಟ್ಗಳು ನೋಡ್ತೀರಾ ಅಂತ. ರಿಲ್ಯಾಕ್ಸೇಷನ್ ಆಸಿಲೇಟರ್. ಕ್ಯಾನ್ ಎನಿವನ್ ಅದರ್ಸ್ ರಿಪ್ಲೈ? ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ?
Sir, like vehicle indicators ಅಲ್ಲ?
ಎಸ್ ಎಸ್. ಅದೇ ತರ ಎಲ್ಲಿ ಬೇಕಾಗ್ಬೋದು, ಎಲ್ಲಿ ಹೈ ಔಟ್ಪುಟ್ ಅಂಡ್ ಲೋ ಔಟ್ಪುಟ್ಸ್ ಬೇಕೋ ಅಲ್ಲೆಲ್ಲ ಯೂಸ್ ಮಾಡ್ಬೋದು. There is another experiment, A-stable multi-vibrator circuit. See, please, you have to practice this. If you practice, then only you will, some question will rise on these topics. Even I can tell for hours about this experiment. When does you are going to get the question on these topics is whenever you connect and whenever you see the output there, then only the question will rise and you can ask us. Just installing the software, it is not enough. Please install and please do the experiment. The next is duty cycle. Do you know about the word duty cycle? ಕೇಳಿದಿರಾ word ಇದು duty cycle? Can anyone reply? Have you heard duty cycle? Okay. See, this duty cycle is you have seen the waveform, right? Waveform, a low and then high. One square wave means there will be a low and high output. In that, how much time will be the low output and how much time will be the high output? How much time will be the low output? What is the length of the square wave? The length of this high output, how much is the length of the low output? If I say 50% duty cycle means the high output and the low output length will be same. If you say length duty cycle is 75%, there any circuit which shares 75%? The internet, or I'll show it in the here. See here the waveform. See the length of this is a square wave. Still it is a square wave. See whatever whenever the square wave, how it should, the length of the low output, see the length of the high output, it is not equal. This is lesser and this is bigger. 75% of the time it will be high output, 25% of the time it will be low output. If it is equal, then you can say 50% duty cycle. If it is 75% duty cycle means high output will be 75%, low output will be 25%. If I say 30%, 30% of the time will be high output, 70% of the time it will be low output. That is the meaning of duty cycle. The length of the high and the low output. Just whenever you write the waveform, how much duration it will be low, how much duration it will be high. That is the meaning of the duty cycle. And what they are saying is you have to design a stable multi-vibrator circuit for 3 different cases. One, 50%, less than 50%, greater than 50% using 555 timer IC. Here they are not saying op-amp IC. Operational amplifier use ಮಾಡಂಗಿಲ್ಲ 555 timer IC use ಮಾಡಬೇಕು. And the waveform should look like 50% means equal. High and low waveform should be equal. Less than 50% means, example, some 40%. 40% of the duration will be high, 60% will be low. Greater than 50%, example on 75%. 75% of the length will be high, 25% will be low. ಆ ವೇವ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ನೋಡಿದ್ರೆ ನಿಮಗೆ ಲೆಂತ್ ಡಿಫರೆನ್ಸ್ ಗೊತ್ತಾಗುತ್ತೆ. In that way you have to design a stable. A stable means a circuit which is not stable at one output. Astable, bistable. There are two types: astable, monostable, and bistable. Monostable means it is the monostable circuit means the circuit output will be only one output, means either 0 or 1, either low or high. Monostable means always it will give 0 output, or it will always give high output 1. That is called monostable. Bistable means the circuit can give the output 0 or 1, like a flip-flop. Bistable circuit. Flip-flops, it's a bistable circuit. It can give 0 or 1. Astable means it cannot be in one state. For some time it will be in 0. After some duration it will switch to high. After some duration it will switch to low. After some duration it will switch to high. That is called astable. It cannot be stable in stable at one circuit, at one output. That is why the name astable multi-vibrator circuit. You have to design that for these three cases. Is it clear the meaning of astable multi-vibrator circuit? ಅರ್ಥ ಆಯ್ತಾ? ಏನಾದ್ರು ಡೌಟ್ ಇದೆಯಾ? The meaning of the word astable. ಯಾರು ಡೌಟ್ ಇದ್ರೆ ಕೇಳಿ. ಡ್ಯೂಟಿ ಸೈಕಲ್ ಅಂದ್ರೆ ಡೌಟ್ ಇದೆಯಾ? ಡ್ಯೂಟಿ ಸೈಕಲ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ a waveform, a square waveform ಅಲ್ಲಿ ಎಷ್ಟೊತ್ತು ಲೋ ಬರೀತೀರಾ, ಎಷ್ಟೊತ್ತು ಹೈ ಬರೀತೀರಾ ಅಂತ. Any doubts? You can send it in the chat also. No doubts? Okay. Easy for me. Assume that it is understood for everyone. Okay. See this circuit, 555 timer IC. Once again, this is a 8-pin IC. 555 timer IC. Once again, it is an 8-pin IC. You have a meaning of astable, monostable, and bistable. In that, which are the pins we are going to use? See this. The input pins we are going to use is here 2, 6, 7. See, once again 8-pin IC. Please see the description of a 555 timer IC. Pin diagram anta search ಮಾಡಿ information ಎಲ್ಲ ಸಿಗುತ್ತೆ. Ground pin ಯಾವುದು, ಅದರಲ್ಲಿ power supply pin ಯಾವುದು. See the power supply pins, VCC pin 1 and 8. Ground pin is 1, power supply is 8. Reset pin is 4. Output pin is 3. Output pin means the output you are going to connect it to the CRO. The trigger voltage, discharge pin, and threshold pin. These 3 pins. In this experiment, if you want to design for greater than 50, less than 50%, here once again you have to design. What you have to design? Some of the resistors and some of the capacitors are fixed. Means we assume the values of that for the experiment. ಈ experiment ಎಷ್ಟು ಬೇಕಲ್ಲ ಅದನ್ನ ನಾವು ಆಲ್ರೆಡಿ ಟ್ರಯಲ್ ಅಂಡ್ ಎರರ್ ಮಾಡಿ ಆ ವ್ಯಾಲ್ಯೂಸ್ನೆಲ್ಲ ಫಿಕ್ಸ್ ಮಾಡಿದ್ವಿ. Some other resistance and capacitors that you have to calculate. Calculate means some formulas are there. You have to substitute the values and you have to calculate. See here, 4th pin, 8th pin, power supply pin, reset pin. You are going to connect it to the VCC. Reset pin, power supply pin, 12 volts connect ಮಾಡೋದು. First pin, we are going to connect it to the ground. You can see the pin diagram. Then there are 2 capacitors we are going to use. One is, this is a reference capacitor. This is not at all required, but still we are using Both the capacitors are fixed here, 0.1 microfarad and 0.01 microfarad. We are not going to change these values. In this, whenever we are doing the experiment, this capacitor gets charged and discharged. 0.1 microfarad, 0.01 microfarad. These two values, these road resistors R1 and R2, 6th and 7th, discharge point and threshold point. These things we have to calculate. Two capacitors are fixed. Other pins, some of the pins are connected to ground and some of the pins are connected to VCC. Just we have to calculate this R1 and R2. For less than 50, you will get some values of R1 and R2, greater than 50 and equal to 50. What are the formulas are there? See this formula. You have to understand some of the word frequency F, time period T, duty cycles, we use the word D, capacitance C. Capacitor charging time, high output what you see, that is called as a capacitor charging time, TC. What is the formula for that is duty cycle into total time. Discharging time, what is discharging time? It is just 1 minus D into T. Totally charging time and discharging time, it will become the total time. ಎಷ್ಟೊತ್ತು ಚಾರ್ಜ್ ಆಗುತ್ತೆ ಎಷ್ಟೊತ್ತು ಡಿಸ್ಚಾರ್ಜ್ ಆಗುತ್ತೆ ಕೆಪಾಸಿಟರ್ ಅದರ ಟೋಟಲ್ ತಗೊಂಡ್ರೆ ನಿಮಗೆ ಟೋಟಲ್ ಟೈಮ್ ಸಿಗುತ್ತೆ ಟೈಮ್ ಪೀರಿಯಡ್. This is a basic formulas. Duty cycle we say greater than 50%. In that case, what is the formula for charging? What is the formula for discharging? 0.693. These things, formulas, we are not going to discuss about the description how we have got this formula. 0.693 into R1 plus R2 into C. What is this R1 and R2? And discharging time, it is 0.693 into R2C. For charging, we have used both the resistors. For discharging, only one resistor. The reason is, see here, we send the input here. Whenever you charge the capacitor, the charges will move through R1 and R2. Illinda move agi capacitor go charge agutte. Whenever it gets discharged ಅಂದ್ರೆ charge capacitor ಪೂರ್ತಿ charge ಆಯ್ತು. ಈಗ discharge ಆಗಬೇಕು, ಆ voltage pass ಆಗ್ತಾ. See the discharge pin is 7. This discharge voltage, it will pass through the R2 and it will enter the 7th pin and it will go through the IC. It will not require R1. That is why in the discharge TD, we have used only R2. Charging ಅಲ್ಲಿ R1 and R2 include ಮಾಡಿದೀವಿ, capacitor include ಮಾಡಿದೀವಿ. Charging time calculate ಮಾಡಬೇಕು ಅಂದ್ರೆ capacitor time calculate ಮಾಡಬೇಕು ಅಂದ್ರೆ this constant 0.693 into R1 and plus R2 into C. Because capacitor, ಈ capacitor charge ಆಗೋದು R1 and R2 ಇಂದ ಪಾಸ್ ಆಗಿ ಬರುತ್ತೆ. ಡಿಸ್ಚಾರ್ಜ್ ಆಗಬೇಕಾದ್ರೆ R2 ಇಂದ ಹೋಗಿ ಡೈರೆಕ್ಟ್ 7th ಪಿನ್ ಅಲ್ಲಿ ಎಂಟ್ರಿ ಆಗ್ಬಿಡುತ್ತೆ. ಯಾಕೆಂದ್ರೆ 7th ಪಿನ್ ಡಿಸ್ಚಾರ್ಜ್ ಪಿನ್. Greater than 50%, less than or equal to 50% ಗೆ ಚಾರ್ಜಿಂಗಿಗೆ ರೆಸಿಸ್ಟ್ R1 ಸಾಕು, ಇದಕ್ಕೆ R2 ಸಾಕು. ಯಾಕೆ ಅಂದ್ರೆ ನಾವಲ್ಲಿ ಸ್ಪೆಷಲ್ ಕೇಸು ಬೈಪಾಸ್ ಮಾಡಕ್ಕೆ ಲೆಸ್ ದೆನ್ 50% ಅಲ್ಲಿ ಒಂದು ಡಯೋಡ್ ಹಾಕ್ತೀವಿ. When it is bypassed, the charge will directly pass through this diode, and instead of removing this resistor, what we are doing is we are bypassing through diode. One diode connect ಮಾಡ್ಬಿಡ್ತೀವಿ, ಅವಾಗ ಇಲ್ಲಿಂದ ಪಾಸ್ ಆಗುತ್ತೆ. ಈ ರೆಸಿಸ್ಟರ್ ಇಂಪಾರ್ಟೆನ್ಸ್ ಇರೋದಿಲ್ಲ. ಹಂಗಾಗಿ ಫಾರ್ಮುಲಾದಲ್ಲಿ ಚಾರ್ಜಿಂಗ್ ಅಲ್ಲಿ R2 ಇನ್ಕ್ಲೂಡ್ ಆಗಲ್ಲ. ಡಿಸ್ಚಾರ್ಜಿಂಗ್ ಅಲ್ಲಿ ಇಲ್ಲಿಂದಾನೇ ಹೋಗ್ಬೇಕು 7th ಪಿನ್ಗೆ ಎಂಟ್ರಿ ಆಗಕ್ಕೆ. ದಟ್ ಈಸ್ ವೈ R2 is included. Capacitor will be discharged through the R2. Capacitor will charge through the R1. That is why this is the formula. ಇದು ನೆನಪಿರ್ಬೇಕು ಫಾರ್ಮುಲಾ. ಇವೆಲ್ಲ ಡಿಸೈನ್ ನ ಬರೆದು ತೋರಿಸ್ಬೇಕು ಟೆಸ್ಟ್ ಅಲ್ಲಿ, ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ. Then what we do is calculation. Duty cycle, frequency. We'll write in the exam what is the frequency. 1 kilohertz, some number 800 hertz, 200 hertz, 500 hertz. Duty cycle, some number we'll write 55%, 60%. The example what we have shown is 70%. ಇಲ್ಲಿ ಏನ್ ತೋರಿಸ್ತಿದೀವಲ್ಲ ಅದು 70%. ಏನ್ ಕೊಟ್ಟಿದ್ವಿ ಫ್ರೀಕ್ವೆನ್ಸಿ ಕೊಟ್ಟಿದ್ವಿ ಡ್ಯೂಟಿ ಸೈಕಲ್ ಕೊಟ್ಟಿದ್ವಿ ಇನ್ನೆಲ್ಲ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೇಕು ಏನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೇಕು R1 and R2 ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೇಕು ಇನ್ನೆಲ್ಲ ಫಿಕ್ಸ್ಡ್ ಇದಾವೆ the values are fixed just you have to calculate R1 and R2 for any cases ಬೇರೆ ಯಾವುದೇ ಕೇಸ್ ಆಗಲಿ frequency 1 kilohertz duty cycle 50% at the end what we calculate R1 and R2 in ಬೇರೆ values ಎಲ್ಲ ಫಿಕ್ಸ್ಡ್ ಇರ್ತವೆ frequency change ಮಾಡಿಲ್ಲ ಅಷ್ಟೇ change ಮಾಡಬಹುದು we can change the frequency and also duty cycle some number 40%. It is not always in terms of tens we have to give 55 46 any number we can give. Frequency ಕೊಟ್ಟಿದ್ರೆ time ಕಂಡುಹಿಡಿಯೋದು ಸುಲಭ reverse of that we will get 1 millisecond 1 kilohertz ನ reverse ಮಾಡಿದ್ರೆ 1 millisecond. Duty cycle 70% ಅಂದ್ರೆ in terms of decimal if you write it is 0.7. Formula we know duty cycle equals Tc by T. T we know it is 1 millisecond. ಅಲ್ಲಿ Tc ಸಿಕ್ತು 0.7 millisecond. Just a normal addition, subtraction, division. If you know Tc, T equals Tc plus Td. Therefore, whenever you subtract, you will get Td. That is also simple, 0.3 millisecond. Simple, charging time total 1 millisecond ಆಗಬೇಕು. Charging time 0.7 ಆದ್ಮೇಲೆ remaining 0.3 ನೇ ಇರಬೇಕು discharging time. We already chosen C equals 0.1 microfarad. Capacitor use ಮಾಡಿರೋದು ನಾವು ಯಾವುದು 0.1 microfarad. Since the duty cycle is greater than 50%, formula is this one, Tc Td. R1 ಗೊತ್ತು, R1 ಗೊತ್ತಿಲ್ಲ, R2 ಗೊತ್ತಿಲ್ಲ. Just leave as it is. Tc ಗೊತ್ತು 0.7. Constant is 0.693. Capacitor is 0.1 microfarad. Keep as it is. Td equals 0.693 R2C. Td you know, R2 you don't know, C you know. R2 ಇಲ್ಲಿ ಸಿಗುತ್ತೆ, ಇಲ್ಲಿ subtract ಮಾಡಿದ್ರೆ R1 ಸಿಗುತ್ತೆ. Finally, you got these two values. And it's normal, simple addition, multiplication, division. No extra circus is required here. Substitution, just subtraction, multiplication, and division. That's all. You will get these values. Then after you have to do this connections. ಇಲ್ಲಿ R1 and R2 ಅಲ್ಲಿ ಏನು values ಬಂದಿರುತ್ತಲ್ಲ resistors ಅವನ್ನ connect ಮಾಡಬೇಕು. ಇವೆಲ್ಲ values fixed ಇರುತ್ತೆ. If you do like this, whenever the capacitor gets charged, input waveform, what we do is the second pin we are going to connect it to the CRO once again. CRO ಅಲ್ಲಿ input waveform ಯಾವ ತರ ಹೋಗ್ತಿದೆ ಅಂತ ನೋಡಕ್ಕೋಸ್ಕರನೇ second pin we are going to connect it to the CRO oscilloscope connect ಮಾಡಿರ್ತೀವಿ. Then you will see the input waveform like this charging. Then output waveform, the third pin also we are going to connect it to the CRO. The square wave will be like this. More equal to 50% ಅಂದ್ರೆ ಈ TC time, the charging time, discharging time, length ನೋಡಿದ್ರೆ same ಇರುತ್ತೆ. If it is greater than 50% means it looks like this. High ಹೊತ್ತು ಜಾಸ್ತಿ ಇರುತ್ತೆ, low ಹೊತ್ತು ಕಡಿಮೆ ಇರುತ್ತೆ. You can see the output like this. High output and low output. See this arrow mark you can see and you can check the scale here. Once again you have to trace back whatever you have got the output whether it is correct or not. By using those scales you have to check. Do I have any doubts in this? If you have any doubts in this, you can ask. I think if you practice this, I'll end the meeting now. Okay, I'll send. Since this is a old manual, but all the possible old manual means the last syllabus. Whatever is required, please only refer that. Don't see the other experiments. Window comparator, it is not there in that. That is why I'm sending now both. So I have sent the manuals in the group. Window comparator, it is in the other PDF. Okay. And the remaining experiments, the previous scheme experiments are still there. Whatever is required for your syllabus, all the experiments are there, all the 8 experiments, and one experiment it is there in the other one, window comparator. See, from now itself, if you write the record, it is good. Whenever you find the time, please write your record. Always what you have to write is the procedure, the left hand side, what you should write. I'll say now itself. Please make a note of it. Don't write this background. All the components, aim, components, result, aim, problem statement also, aim, components, and result on the ruled side. Left hand side, unruled side, you have to write all the other things. All the other things means the design part, the circuit diagram, all the other things, the table, procedure also right hand side, procedure also ruled side. Aim, procedure, components, result statements on the ruled side. Unruled side, circuit, design, and last table. This table that you have to write on the left hand side. You write it for 3 experiments. ಈ 3 experiments ಗೆ ಬರ್ದಿರಿ. Is it clear? Whenever you find time, please write this 3 experiments. As and when we do the experiments, manual ಇದೆಯಲ್ಲ, ಇನ್ನೇನು ಬರೆಯೋದೇನು ಕಷ್ಟ ಅಲ್ಲ. ನೀವು ಬರೀತಿರೋ, ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ ಹತ್ರ ಬರೆಸ್ತಿರೋ, ನಿಮ್ಮ ರಿಲೇಟಿವ್ಸ್ ಹತ್ರ ಬರೆಸ್ತಿರೋ, that is left to you. I know there are so many different sources you use it, but please write the record for these 3 experiments. And if you got the doubts, whenever you do it in the simulation, please ask me. From next lab, we'll discuss the digital experiments. If you raise any doubts, then we'll discuss once again the analog experiments in the next lab, or else we'll start the digital experiments. The design of that, I'll explain it in the next lab. Do you have any doubts? If you have any doubts, you can ask. I'll reply. If you don't have any doubts, then I'll end the lab. No doubts? See, anyone, if you have sent only just present, sir, please send your USN and name. Don't send present, sir. Just you have to send your USN and the name. Okay, then if you don't have any doubts, you can exit then. Thank you. Please practice these 3 experiments. From next lab, it is a digital experiment. Please don't send as present, sir. Please send your USN and the name, Amit Iyer. Amit Iyer, are you there? Okay, we'll end the meeting. Thank you.